Welcome to today's lesson. My name is Tyria Danka Samuel. Alright, now the topic under consideration is indices. So in mathematics, when we talk about indices, we mean powers or exponents. That's the meaning of indices. Alright, so when you see something like this, okay, this one is pronounced A exponent B, or you can say A raised to B. Alright, so we call this one base and this one power or index or exponent. So it has many names. We have similar one here. Okay, this is the base and this is the power or index. Alright, now if I write 5 exponent 3, now the number up here is the number of times, okay, number of times this number down here is multiplying itself. Okay, for instance, 5 to the power of 3, it means the number down here is multiplying itself 3 times. So we have 5 times 5 times 5. So they are how many? They are 3. So that's a 3 here. So when we go back, so A exponent B here, the B here is the number of times the base here is multiplying itself. That's the meaning. Alright, so we can search for so many examples. We can talk about so many examples. So 5 to the power of 4 means 5 is multiplying itself 5 times and what have you. So if I write 5 exponent 100, it means 5 is multiplying itself 100 times. As simple as that. Alright. Now, before we can deal with so many examples under this topic, there are rules we need to follow. Alright, so let's quickly talk about the laws of indices. Okay, so having known the definition and some of the important part of this topic, let's talk about this. So this one will lead us to how to solve examples under this topic, but we need to understand this one well, else we find it difficult to deal with the examples. Okay, so let's start with the first law. So I will start with the multiplication law. Now A exponent K times A exponent T. Now understand that the law, okay, the laws only hold only when the bases are the same. So the first law can only hold if the bases are equal. So let's check the bases. We have A here, we have A here. So once the bases are the same, we can apply the laws. Okay, so the first law here says that when the bases are the same and they are multiplying, we pick one of the bases and we add the power. So we have K plus T. Simple as that. So this is K, this is T. So we add them here. Simple as that. So when you see example like 3 exponent 4 times 3 exponent 2, now the bases are the same. So we have 3. So we have 4 here. Let's add the powers. And we have this plus 2. So the final answer will be 3 exponent 6. That is the first law. All right. Now the second law is in line with the first one. Okay. So I'll repeat the same thing. A exponent k, but this time is division. Okay, it's division. So the second law talks about division. Now, when the bases are the same and you are dividing, we subtract the powers. So that will be A. We pick one of them. So we have K here minus T. That's the second law. It's very, very important. Okay. So that is A exponent K minus T. You can have so many examples here. So 7 exponent 5 divided by 7 exponent 3 is simply 7 exponent 5 minus 3. So we have this. So the final answer here will be 7. 5 minus 3 is 2. So we can say 7 squared, which is simply 49. All right. Now, note, understand that, okay, A exponent K divided by B exponent T is not the same as A, okay, A exponent K minus T. Why? Because the bases are not the same. So don't try this. It won't work. It's not equal to that. Okay. All right. Now let's talk about the power of product of numbers here. Okay. Now let's observe this. A exponent n or exponent k. So we have two variables here. Okay. This one is a pair and this one too is a pair. So once they meet like this, they can multiply. So here I can say A exponent nk. And we can interchange this one. Okay. So of course you can see this, they are the same as this because multiplication is commutative. This one is the same as this or that. All right. Now, knowing the laws here, let's observe the following examples. Okay, very important. All right. So let's observe the following examples. Now, the first one, we have the first parenthesis, okay, and the second parenthesis. The first one contains 2x exponent 5, y exponent -1. And the second parenthesis is made up of 4x cubed y squared. All right, so how do we simplify this? Okay, now let's understand that this one and that they are multiplying. So when we see two parentheses or two brackets like this, it means they are multiplying. So with this, the numbers will multiply. Okay, so we have 2 times 4, that is 8. We multiply the numbers, and the letters will also multiply. So we have x to the power 5 times x to the power 3. So x to the power 5 times x to the power 3. Remember the first law of indices, which says when the bases are the same and we are multiplying, we simply add the powers. So we have x to the power of 5, x to the power of 3. We just add the powers, making x to the power of 8. As simple as that. And the next one will be y. Okay, we have y exponent -1 times y exponent 2. So that will be 2 plus -1. So we have 2 cedis, and you are owing someone 1 cedi. So when you pay the debt, you will have it additional 1 CD. So that will be y exponent 1. Okay, for now, let's maintain the 1. When we get to the properties, you know that any non-zero number to the power of 1 is still that number. So this side will still be y, but let's maintain it as that. Okay, now the II2 is in line with the third law. So we have x squared, we have squared here and I have 4 here. So, sorry, that will be 2 times 4, and that's 8. So we have x to the power of 8 as the answer. And the third one, 7 exponent 6 divided by 7 exponent minus 7. Let's take the basis. You have 7 here, 7 there, 7. You have 6 minus. Be very careful here because we have minus here already. So 6 minus. So the division here will pave way for this. Okay. And we have minus 7. So that will be minus 7. Minus minus will be plus. So that will be 6 plus 7. And my final answer will be 13. So that will be 7 exponent 13. So you can try this one, okay, and put the answer under the comment section below, okay. So 2 to the power of minus 4 divided by 2 to the power of minus 3. So let's check this one out. All right. Now let's talk about the properties of indices. So let's start with a to the power of 0. So this one is any non-zero number. So when we say non-zero, it means not 0. Okay, so we can write this example 0.00001. This one is non-zero. So any non-zero number to the power 0 is 1. So this side is 1. So any non-zero number, you can talk about so many examples. Okay, so any non-zero number, a number which is not 0 to the power of 0 is 1. So don't ask me that, say what is 0 to the power of 0. Okay, we are not dealing with this one here. We are talking about any non-zero number. So the base here can never be 0. It's non-zero. Okay, so that's that. It's 1. And the second property has to do with any non-zero number to the power of 1. So you can say a to the power of 1 is a. That is why I said this side, when we prove further, we'll get y here. So we now know that any non-zero number to the power 1 is that number. Now let's talk about the power of product of two numbers. So when you see a m exponent x, now understand that the power here is 1 and this side too is 1. So this one will affect this and affect that. So we can say e to the power of x, m to the power of x. Okay, so tomorrow when you see 5 to the power of x times 4 to the power of x, because we have this one in common, you can take it out. So that will be 5 times 4 all to the power of x. So it's in line with this. Let's check this one out. So we have a times m here all to the power of x, and the same as a to the power of x, m to the power of x. So this one will be 5 times 4, that is 20 to the power of x. All right, now let me throw more light on the power of product of two numbers. So let me throw more light on this. Now let's observe this. 3 to the power of 2 times 5 to the power of 2. Now because we have 2 in common here, we can take them out. So I will leave with this 3 times 5 all to the power of 2. So 3, 5, 15. That will be 15 squared. So y squared m squared is the same as ym all squared. T squared r squared, that will be t r squared. Z to the power of 3, m to the power of 3, that will be zm or cube. Alright, so that's that. So we have so many examples. Now let's quickly talk about the negative index. Negative index, okay? So understand that index means power. So when you hear negative index, you should be thinking of this. Okay, something of this nature, okay? We are talking about this group of numbers. So whereby the powers are negative. So they are called negative index. Now, when you see a exponent minus 1, it's the same as 1 over a. So 1 over a in going back is the same as a exponent minus 1. Okay, now a exponent minus 2 will still be 1 over a to the power of 2. Okay, now understand that 1 over something will get rid of negative here. Okay, and what is here will be here. So we have 1 here, 1 here, we have 2 here, 2 there. So it means 5 exponent minus n, that will be 1 on 5 to the power of n. Okay, so the minus here is 1 over. So when immediately 1 over, once you see this one will vanish, and you will have this one here. So this one will be 1 over 2, and this one will be 1 over b to the power of n. This one will be 1 over c to the power of n, and this one will be 1 over r to the power of p, and many more. So you can try the following: 7 exponent minus c, 10 exponent minus p, 25 exponent minus 7. So you can try them. All right. Now let's talk about the power of quotient of two numbers. Now when you see this, these are all properties: a on b all to the power of n. So that will be a to the power of n. Remember, this n will affect this. We have 1 here, we have 1 there, so times 1 will be n, times 1 will be 2 to the power of n. So tomorrow when we see 5 exponent 2 on 3 exponent 2 is the same as, so 2 here, 2 there, n here, n there, we have n out. So 2 here, 2 there, 2 out, 5 on 3 all raised to 2. As simple as that. So we can have so many examples: y to the power of p on x to the power of p on y to the power of p. That would be xy all to the power of p. As simple as that. Now let's talk about the negative power of quotient. Negative power of quotient. Okay, the negative power of quotient. So I'll build my point based on this. So a on b all to the power of n. Okay, now this time I will negate this. It's a property. So once you see this, is the same as, so the reciprocal of a and b here, b over a, all to the power of n. So once we reciprocate this, this side also change to positive. So in dealing with this, let's say 2 on 3 all raised to minus 2 is the same as 3 on 2 all raised to 2. Okay, so x on 8 all raised to minus 3 is the same as 8 on x all raised to 3. Understand this? Okay, so observe this. 4 on 3 raised to minus 6. So what is the answer here? So you can put the answer under the comment section below. All right.